Hello. Okay, so I wanted to make a video to, excuse me, to show you how to do all of those z-score and normal probability stuff on your calculator. I know I talked through it a little bit in class today, but I figured I'd show you as well. So here is my example. So I'm going to do with IQ scores because I happen to know these numbers. So I say they're normally distributed, the mean is 100, and the standard deviation is 15. So we want to find the percent of IQ scores between 80 and 105. So I always like to go from a picture, so I'm going to do my best to use this Microsoft Paint. So bear with me, it's going to kind of suck. So there's my straight line, and here is my curve. 100 is right there in the middle. So I want to go between 80, which I'll put over here somewhere, and what is it? 105, which I guess is over there somewhere. And I'm looking at this area right here. Okay, so before I'm going to do anything, just like the table, calculator table as well, I have to change these data, raw data, 80 and 105, into z-scores. So the formula for that is going to be z equals data minus mean divided by standard deviation. Now on this one I have two different numbers, 80 and 105. So I'm going to turn both of these guys into z-scores. Okay, so for one, I'm going to say 80 minus 100 divided by 15, and that equals, here, I got my calculator here, that's 80 minus 100 divided by 15, at negative 1.33. And the other one, 105 minus 100 divided by 15. Oops. I guess that's 5/15. Is that 1/3? It probably is. It is. So between negative 1.33 and positive 0.33. So that's this guy right here, negative 1.33 and positive 0.33. So I'm going from left to right, from negative 1.33 to positive 0.33. Okay, so I go on my calculator here. So like I said, it's under distribution, which is right here over vars. So second, vars to get the distribution. I want the normal CDF, cumulative distribution. I never want P, always C. So I'll do that, he's number 2. Mine pulls up like this, right, where I have the open brace and I put things in. It might pull up a different menu where you give you left bound and right bound, set mean to 0 and standard deviation to 1. But if it looks like this, it doesn't really matter. Let me see, so I want to go from negative 1.33 to positive 0.33. And there goes my answer right there, 53.75%. All right. I'm going to find the percent below 95. So here's what I'm going to do. Same thing, but I want below 95, which will be over here somewhere, and I want less than it. So I've got to convert this 95 into a z-score, so I do. Always have to convert it to a z-score. It only works once we've standardized these scores. So 95 minus 100 divided by 15. I guess that's negative 5 over 15, right? So that's going to be negative 0.33. So when you're going less than this negative 0.33, I mean, our calculator only does left to right. So I have to pick a value out here, something like negative 10. Distribution, normal CDF, I go negative 10 to negative 0.33. And there's your answer, 37%. Now, I say negative 10, I think I said in class, it's just something very negative. You realize if I change that negative 10 to like negative 100, I get the same answer. Look, exactly the same. In fact, even if I was going to go negative 8 to negative 0.33, I get the same thing. Even if I'm changing them all the way back to like negative 5, if I'm rounding to 4 decimal places, I still get the same answer. So when I say that thing that I'm picking to the left over here, it could be a whole lot of possible numbers. I guess don't pick 4, but anything bigger than 5. I usually pick 9 or 10 just because they're nice round numbers. But anyway, which way you look at it, about 37%. If I want to go above 110, that's going to be 2/3. Now I'm going left to right. I want it above 110, so I'm looking this way. So I'm going to pick from my guy, 0.67, off to something big. .67 off to something big. I don't know, like 8. Just one of these top numbers, pretty much. We're doing, there you go, about 25%. Okay. Now going backwards. So those are pretty easy, right? Normal CDF, that's the cumulative distribution function. You're putting in z-scores, it's spitting out area, right? So that's your actual function. Cumulative distribution. Sticking in z-scores, spitting out area. No, go away. Now, this other problem asks for the IQ score that's separating the highest 15% from the lowest 85%. So when I have my curve now, I'm given that area, and I want this data right here. So if the normal cumulative distribution function inputs z-scores and outputs area, I guess the inverse of that is going to input area and output z-scores. So I do that. I give you 3 for inverse norm because I've given an area, or percentage of the data. Put in 0.85. That's going to spit me out a z-score of 1.04. And then I can just convert back. So similar to this guy, I can say x equals mu plus z sigma, which in this case is going to be 100 plus, what did I just say he was, 1.04? 1.044 times 15, which is what? 100 plus 1.04 times 15, 115.6. And there you go. Right, basically, normal CDF, put in z-scores, get out area. Inverse norm, put in area, get out z-scores. So it just depends on what they're asking you for. It says find the IQ score. I'm given a percent. I want the inverse norm. It says find the percent. I'm given some data. You got to use normal CDF. Or you can use those tables just like I showed you in class today. Either way is fine with me. But, okay, if you have any questions, let me know. And I'll see you next week.